In this video, I'm going to be going over how to do a segmentation in Slicer. Segmenting is the crux of working with CT data. Essentially, you're labeling all of your structures of interest with different colors, and then you can export those to 3D models that can be used for further analysis. It can be a very complicated process, especially dependent on the quality of the CT data. So to give you an idea of how this might work, I'm going to start by showing you a finished example. Right here, I have a photogrammetry model of 3 vertebrae that are fused together. I am interested in the structure of the diaphragmatic vertebrae, which is this one right here. However, in the physical specimen, these 3 vertebrae are stuck together, so I couldn't see what the front part of this vertebrae looked like. That is why I decided to CT scan this specimen. So now if we go over to Slicer, in this 3D view, you can see I've already cropped down to just this vertebrae plus the little bit of the one it's stuck to. And we can start in the slice view looking at the scan in Slicer. As an aside, you might notice that this is a very messy scan, and that's because there were these very dense mineral concretions inside of the fossil that we didn't know about when we scanned it and didn't really account for. So that's why you'll see these. You can see it almost looks like they're shiny, and that just has to do with how the X-rays were diffracting off of it and creating artifacts. That's also what's causing all these lines you're seeing. These aren't actual structures in the fossil, they're just artifacts from how the X-rays were taken. And this will actually play into how this was segmented. Now I have switched my red slice view so it is directly at the intersection between these 2 vertebrae. Right here, you can see the articulations of the diaphragmatic vertebrae, which is the one I'm interested in, and how closely they're connected to the other vertebrae that is in front of it, which is what the rest of your seeing is. You can see this point very clearly on the volume rendering where I've displayed the red slice, and I did that just by going up here and clicking this little eyeball. So now, in order to segment, basically what we want to do is color in the structure of interest, in this case, which is just the diaphragmatic vertebrae. In this case, I've already done that, and I can go display my label map, which is the term for where all of your segmentations go. In this case, there's just a single color because I was only interested in the 1 vertebrae. Now, as I scroll through, you can see that the diaphragmatic vertebrae, the one of interest, is marked, and that the structures that I'm not interested in, which would include the surrounding air, the matrix inside the vertebrae, and the second vertebrae, are all left unmarked. From this, Slicer can generate what Slicer calls a model, which can be exported as a mesh and used for other applications. And if I turn off the volume, you can actually see what this looks like. You'll notice this one is very messy. That is because I had to do it all by hand, and I used some smoothing functions later on to create this finished model. Still a little bit messy, but in better shape than the previous one. And now you'll see that this has the same properties of a mesh as we discussed earlier, where if I look inside, there's not actually anything in here except maybe a few floating polygons that should be gotten rid of anyway. I've loaded this rodent jaw fossil scan into Slicer to demonstrate the different segmentation tools. Before I get started with that, though, I wanted to note that I have installed an extension using the Extensions Manager called Segment Editor Extra Effects. This adds some extra tools that can be really handy when segmenting out more complicated scans. To get to the segment editing tools in Slicer, you'll just go to the Modules menu and go to the Segment Editor module. The first thing you'll see here is the Segmentation menu and Master Volume menu. Master volume is just the volume that you're working on, whereas segmentation is the object that's going to hold all your segments. Slicer will just make one and default name it segmentation, so it's fine to leave it like that. Now you're going to add a segment. You can set the color by clicking on the color box, and the name is also an option. So I could name this one jaw, and then I can pick really any color that I want to work with. Now, how many segments you have is going to depend how many structures you're segmenting out of your scan, and that's really going to be project dependent. For our project, we've been segmenting the jaws as a whole, which requires me only to make one segment. However, if we wanted to segment out each individual tooth, I would make 5 segments, one for each tooth, and then one for the jaw. Now if I scroll down, you'll see all of these tools that are available to segment. As you may have guessed from looking at the example I showed earlier, segmentation can be a really subjective process, and there's no hard and fast rules for how to do a segmentation. It's all going to depend on your scan and who's working on it. This means that it's important to document what you're doing as you're working on a segmentation, so that if anyone uses the meshes you create in the future, they know exactly what you did to get them. The first tool I want to demonstrate is called the threshold tool. This is probably the easiest and most common one to use. Right now you can see a preview of what the threshold tool is selecting. Basically, it will select all of the pixels in between 2 intensity values, so black to white, which represents the density of the specimen. Right now I've got it set to a threshold that will select all of the fossil, but none of the matrix or surrounding air. If I adjust the lower threshold down, you'll see more and more of the matrix starts to be selected, and then finally even the air surrounding the specimen is selected. On the other hand, if I adjust the higher threshold down, it starts to unselect the highest density values. This is about where I'm going to set my threshold so I can get all of the fossil without any of the matrix. All I have to do now is click apply. And now as I scroll through this specimen, you can see that it hasn't just applied these colors to my one slice, it's applied it to the entire volume. I can preview what this model will look like by clicking on the Show 3D button. I'm pretty happy with how this model is looking, and I could export this one right away for our project. When thresholding works, it's great. However, sometimes you're just not going to be able to use thresholding to split out your structures of interest. For instance, if I want to segment out just this tooth, a threshold isn't going to cut it. So I've cleared out my segmentation so I can show you some of the tools Slicer has for creating finer detail segmentations. First, let's hop into the red slice view so that we can get a closer look at the scan we're working with. I'll add my new segment to work with. And now I can show you the most basic tool Slicer has for this kind of segmentation, which is the paint tool. As you might imagine, it allows you to just paint directly on your structure of interest. You can also adjust the size. Now, one thing to keep in mind is this paint tool is only going to work on the slice that you're currently viewing. So if I scroll away, you'll see you no longer see the green paint on my slice. There is a way around this where you can select the sphere brush tool if you click this check mark over here. And now if I paint and I scroll, you can see a little bit of it has gone through to other parts of the slice. This can be good if you know you're going to be working with a relatively continuous structure, such as right here. But you will end up having to do a little bit of editing and erasing. There is also a very handy masking tool where you can select editable intensity range. This means that when you paint, you will only be painting over intensity values of the selected, you will only be painting over pixels in the selected intensity range. So for instance, right now, I can color over this entire area, and only the parts that are above the lowest intensity values are selected. Slicer's erase tool just works in a similar way to the paint tool in the opposite way. So it also has the sphere brush options, diameter selection, and this editable intensity range. However, it just erases parts of the segments you don't want. So for instance, where I covered a little bit there. So you can actually get pretty far with just the paint and erase. and editable intensity range on those two tools. So for instance, marking up this tooth, I've got paint selected, and I can actually increase the size of this brush pretty far, and then I can just color over the tooth. Now, I am using a drawing tablet because I find that helps with kind of the fine motor movements needed for some of the detailed areas, like by the root. But you can see I actually managed to fill in my area of interest pretty quickly. However, obviously, this is going to be time-consuming to do slice by slice. So there's a couple of tools you can use to supplement this kind of manual drawing process. The first I want to show you is level tracing. Now, I haven't personally found this to be helpful too often, but I can definitely imagine situations where it's good to know about. Essentially, it selects all the pixels in an area that are similar to each other. So I can move it around and try and make it so it's only selecting the tooth. Okay, so it hasn't selected the entire tooth, but it's selected a lot of the stuff bound by the roots that's harder to paint. So I can just repaint over it with my paint tool, the parts that it missed. And aside, this is the only time you can undo things in Slicer. Okay, so, I've painted some of these slices, but it is still going to be time consuming to go through and paint all of them. However, the Segment Editor Extra Effects extension actually adds this really neat tool called Fill Between Slices. So you'll see I've already gone through and painted a bunch of the slices about every 5 to 10. So that there's enough information for the fill between slices to interpolate. If I just click fill between slices and then click initialize, you'll see it filled in on this slice that I hadn't colored in yet. And as I scroll through, you can see it's actually done a pretty good job of interpolating where the tooth is based on the slices I had already painted. Definitely not a perfect job, but I can go back and fix these later. So let's hit apply. And I can actually go back up into the 3D view and preview what this looks like now. Okay, so it's looking pretty good, but not great. I would still want to go back and do some erasing. However, I want to get to some of the other tools that you might find useful. Okay, so I've switched over to a different scan to show some other tools. You'll notice that this one is much grainier because there were some issues with scanning it, or the settings weren't set correctly, something like that. And to be quite honest, segmenting something like this is just going to take a lot of time depending on what you want to do. But I'm going to be using it to show one of the easier tools to use, which is called the Islands tool. So first, I need to just apply a segmentation that'll generate a fair amount of little islands. Okay, you can see a lot of these little dots and artifacts in here, and the Islands tool can be good for getting rid of those. So you have many different options with the Islands tool. I tend to stick with Keep Largest Island because I'm just going for one complete structure of my segmentation, but there are instances where you may prefer to remove small islands or split in the islands into different segments. For instance, down here you can see there's another part of a jaw, so if I had 2 jaws, I could just automatically make them different segments, etc. So let's just do Keep Largest Island. Okay, now you can see the segmentation down here has been erased. The other tool I wanted to show is actually called Grow from Seeds. And basically this one works by marking roughly areas you are interested in being contained within a segment, and then using the algorithm to grow from those seeds. So I'm going to mark this up real quick in an example kind of way, and then we can test it out. Okay, so now I have Grow from Seeds set up. I forgot to mention that you need 2 segments for this method so that the algorithm knows that where the boundaries are for each segment. So for here, for instance, I've got my seeds marked out for the tooth and then a seed marked out for the jaw. If I wanted to do this properly, I would go through and do this on several more slices to make sure it covered the whole extent of the tooth. Right now I really just have it on 2 slices because just for it not to take as much time. But then if I go to Grow from Seeds and click Initialize, you'll see this actually worked quite well, like surprisingly well for how little work I put into making it. Now it didn't spread across the whole tooth because again I didn't mark the whole tooth, but as you can imagine this would be quite a time saver for doing the whole markup of a tooth. And that's all of the tools that I'm going to be covering. As you can clearly see, there are several more tools available. And if you're struggling with a certain thing, I do recommend just playing around with the tools in Slicer, experimenting with them, and seeing how they work with your given scan.